You think you understand gravity. You felt it your entire life. You drop a ball, it falls, you jump, you come back down. Simple, obvious. Newton figured this out 300 years ago. Okay, explain it to me. What is gravity? How does the Earth, sitting 6,371 kilometers below your feet, reach up and grab you? Through what? How does it know you're there? Most people say something like mass attracts mass or it's a fundamental force, but that doesn't explain anything. That's just renaming the mystery. You've replaced why do things fall with because gravity and called it understanding. The truth is stranger than anything Newton imagined. When you really understand what gravity is, what it actually is, according to the physics we've tested to 11 decimal places, you discover something that should break your brain. You're not being pulled down. The floor is accelerating up into you, and that's not a metaphor. That's measured reality. The standard explanation goes like this. Mass attracts mass. Earth has mass. You have mass. Therefore, Earth pulls you toward it. Newton wrote down the equation in 1687. Case closed. It's not wrong, exactly. It's just completely missing the point. Newton himself knew this. He called gravity action at a distance and admitted he had no idea how it worked. How does the Earth reach across empty space and tug on you? Through what medium? By what mechanism? Newton's answer was honest. I frame no hypotheses. Translation, I don't know and I won't pretend to. For 228 years, nobody could answer that question. Then Einstein did, and his answer wasn't a refinement of Newton's force. It wasn't a better equation for the same idea. It was a complete demolition of the concept. There is no force, there is no reaching, no pulling, no invisible fingers. There's just geometry, curved spacetime, and the floor accelerating up to meet you. Start with something you can feel right now. Feel that pressure of your feet against the floor, your hand against a desk. That resistance, you felt this your entire life. You call it weight. You assume it's gravity pulling you down, and the floor simply getting in the way. That assumption is wrong. Here's what Einstein realized in 1907. Imagine you're in an elevator. The cable snaps. You plummet toward the ground. What do you feel? Nothing. You're weightless. Your feet lift off the floor. If you released a ball from your hand, it would hover right next to you, falling at exactly the same rate. This isn't a thought experiment. Astronauts experience this constantly. The International Space Station is falling toward Earth right now, moving sideways fast enough to keep missing it. Everyone inside is weightless. No gravity? Wrong. Gravity is still there, about 90% as strong as on Earth's surface, but they don't feel it because nothing is stopping their fall. The difference isn't how much gravity is present. The difference is whether something stops you from falling. So here's the question nobody asks. If you only feel gravity when something blocks your fall, what exactly are you feeling? It's not gravity pulling down, it's the floor pushing up. Einstein asked a simple question nobody had thought to ask. If you're in a sealed box in deep space and you feel weight, your feet press against the floor, you drop a ball and it falls. Can you tell whether you're on a planet with gravity or in a rocket accelerating through empty space at 9.8 meters per second squared? No, you cannot tell the difference. There is no experiment that can distinguish between gravity pulling you down and a floor accelerating up into you. Einstein didn't say these two situations are similar. He said they are identical, the same thing, the same physics, the same reality. This is called the equivalence principle. It's been tested to 11 decimal places. Every time we test it, it holds. Space and time aren't separate things. They're woven together into a single fabric, space-time. And mass bends this fabric. Not metaphorically, actually bends it. The Earth's mass warps the space-time around it. When you're standing still on Earth's surface, you feel like you're not moving, but you are moving through space-time. And here's Einstein's insight. When space-time is curved, standing stationary in space means accelerating through space-time. GPS satellites have to account for this. Time literally runs faster in orbit, where space-time is less curved than on Earth's surface. If we didn't correct for this, GPS would drift by about 10 kilometers per day. The technology in your phone depends on Einstein being right. When you drop a ball, what path does it follow? Newton said a curved path, bent by the force of gravity. Einstein said a straight line. The ball isn't being pulled, it's traveling in a perfectly straight line through curved space-time. Near Earth, space-time is curved by the planet's mass. A straight line through this curved geometry happens to arc toward Earth's center. The falling ball isn't being pulled down by any force, it's going straight. It's following the natural geometry of space-time itself. And here's what that means for you, standing on the ground right now. The floor is preventing you from following your natural path. You should be falling. The straightest path through curved space-time near Earth leads toward the center, but the floor won't let you. The electromagnetic forces between atoms in your feet and atoms in the floor push upward, accelerating you away from your natural trajectory, constantly. Every moment you stand still. That acceleration is what you feel as weight, not gravity pulling, the ground accelerating. In general relativity, gravity isn't a force at all, it's the curvature of space-time, and what you call the force of gravity is actually you being accelerated away from freefall by whatever surface holds you up. There is no force pulling you down, there never was. What you feel as weight is the floor accelerating upward into you at 9.8 meters per second squared, preventing you from following your natural path through curved space-time. The ball you drop isn't being pulled, it's being left behind. When you release it, you stop forcing it to accelerate with you. It resumes its natural straight line through curved space-time. That path diverges from yours, so you watch it fall away. But from the ball's perspective, it's not falling. It's floating, weightless, following the most natural path in the universe. You're the one being pushed. The astronauts on the International Space Station are 400 kilometers above Earth. Gravity there is 90% as strong as on the surface. They feel nothing. They're weightless because nothing is stopping them from following their natural path. In Einstein's framework, they're not in zero gravity. They're experiencing space-time exactly as it is, uninterrupted by acceleration. You, on the ground, feel heavy, not because you're experiencing gravity. You feel heavy because you're being prevented from experiencing it. True gravity, pure, unimpeded space-time curvature, feels like nothing at all. Weightlessness isn't the absence of gravity. Weightlessness is gravity, experienced purely. Weight is the interruption. This isn't philosophy. This isn't interpretation. This is measured, tested, proven physics. The same curvature of space-time that pins you to your chair also keeps the moon in orbit, not because Earth pulls it, but because the moon follows a straight line through curved space-time that happens to loop around Earth endlessly. It bends light from distant stars. During a solar eclipse in 1919, Arthur Eddington measured starlight curving around the sun exactly as Einstein predicted. Light has no mass. Forces don't pull on it, but it follows geodesics, and geodesics curve near mass. It slows down time. Clocks on GPS satellites tick faster than clocks on the ground by 38 microseconds per day. Not because something's wrong with them, because time itself runs slower in curved space-time. Your head ages faster than your feet by about 90 billionths of a second per year, measurable. It creates gravitational waves. When massive objects accelerate, black holes colliding, neutron stars merging, they send ripples through space-time itself. LIGO detected these in 2015, the fabric of reality, vibrating. What looks like gravity, orbits, light bending, time dilation, and black holes are all one thing, curved geometry. The universe isn't full of forces pushing and pulling objects around. The universe is a four-dimensional shape, and everything moves in straight lines through that shape. So what is gravity? Not a force, not an invisible hand reaching across space. Gravity is the shape of space-time itself, curved by mass and energy, and what you experience as being pulled down is actually being pushed up, accelerated away from your natural freefall by whatever surface holds you. Newton gave us a beautiful tool. His equations work. We still use them to launch rockets and calculate orbits. But Newton himself admitted he didn't know what gravity actually was. Einstein told us, and the answer wasn't a force we couldn't see. The answer was that there's nothing to see. No mechanism, no transmission, no reaching, just shape. Mass tells space-time how to curve. Space-time tells mass how to move. That's it. That's everything. Orbits, tides, black holes, the expansion of the universe, all geometry. You've spent your whole life feeling pushed when you thought you were being pulled. Your intuition was wrong, but the truth is more beautiful than intuition ever promised. Not a force pulling you down, curved space-time, and a floor in the way. The next time you stand up, remember, you're not fighting gravity. You're being stopped from falling through the universe.